All
Well,
right.
I saw that.
And then just a heads up, you can keep your cameras off during this session because it's being recorded. There's no need for you to have your cameras on.
Okay.
But if you do have your cameras on, it will be on YouTube. Just a heads up.
I know. I saw it.
Okay, cool. So out of 27 ice creams, 9 of them are chocolate flavored and the rest are vanilla flavored. What fraction of the ice creams are vanilla flavored? So if 9 of them are chocolate, that means 27 minus 9 is equal to 18 is equal to vanilla, correct?
Yeah.
And then 18 out of 27, what's that? 18 divided by 3 is? Oh, actually, can you divide? No, divided by 9 is? Divided by 9 is?
2.
27 divided by 9?
3.
3.
Yeah.
Perfect. So the answer is 2/3 and the answer is B. Pretty straightforward, right? Next question. Oops, sorry guys. All right, next question. Paper bag contains 4 green lollies, 8 yellow lollies, 1 blue lolly. James picks a lolly from the bag without looking. What is the chance of picking a green lolly? So how many lollies are there in total?
13.
That's
13.
right.
13.
There's 4 green lollies, so it's just 14 out of 13.
Yeah.
So just for those students who don't know, when you do probability is as basically like to find the probability of anything, it's as simple as basically on the top end, outcome that you want. So basically what you want goes on the top. And on the bottom is number of all possible outcome. Right?
Numerator and denominator?
Yeah. So let's just say, for example, you're trying to figure out the probability of, I don't know, that it's going to rain tomorrow, right? The probability that it's going to rain tomorrow. Now you look at historical data, and you know that for the in the past 100 years, 90. Oh, oops. You know that for the past 100 years, for 99 of those 100 years, we've had rain. But 1 year, we had no rain. So what's the probability that tomorrow will be rain? So the outcome we want is rain, so 99. And then the total number of outcomes that we've actually recorded or we have is 100. So the outcome is 99% likely that it will rain tomorrow. Do you guys understand?
Not really.
Yes.
So who doesn't understand? That you don't understand? Could you tell me which part do you not understand?
Understand.
Sorry.
I don't really understand the part where you get like the possible outcome things.
Yes. So basically in this one, I've just said in the description, like when I said this question, right? That it's the how many years that we've tracked. So we said that there's 100 years that we tracked so far. So the total number of possible outcomes is 99 we've recorded as rain and 1 as no rain. So that's why it's 100. You understand?
Yes.
Yeah, that's why.
Yes.
All right, next question. So I've asked students to not spam regularly. So I've had one student spamming about the writing topic. We have sent the writing topic into the WhatsApp group chat, but if you stay patient with me, I'll show it to you at the end of the chat, okay? But if you keep spamming, the problem is that it's just a distraction because it keeps coming up on my screen and it just stops the lesson. So yeah, guys, I'm more than happy to help you out, but just, please remain patient. Thank you. All right, so question number 3. A ticket is chosen at random from a hat. The probability that the ticket is green is 1/12. The probability that is blue is 5/12. What is the probability that the ticket is neither green nor blue, or neither blue nor green? So in total, what's the total probability of something happening? You getting a ticket or any color?
Wow.
Yeah, it's 12. You guys understand?
12.
Yep.
Yeah, or one hole, because you have, there is a ticket inside, right? Now, 5 of them out of the 12 happened to be blue, and then one of them happened to be green. So how many of them are neither blue or green?
6.
That's right. Because if you add them all up, you will get one full probability. Do you guys understand?
Yes.
Yes. Yeah.
So someone sent me in the chat asking me, how did you get one whole? Because that's just the total probability of something happening. It has to all add up to one whole. So for example, if I ask you, what's the probability that tomorrow will be rain? It will rain tomorrow. The probability of it raining tomorrow and it not raining tomorrow has to add up to one whole. Do you guys understand? Because it has to be one or the other. It can't be neither of them. It can't be not rain and raining at the same time. You guys understand?
Yes.
Yes.
Yeah.
Yes.
So the answer is,
what's the answer for question 3?
yes. So I'm doing it. So it'll be 6 out of 12, as we mentioned, right? Now, what is 6 out of 12 the same as?
Half.
That's right.
1/2.
1/2. Good. Okay. Does everyone understand? Can I move on to the next question?
Yes.
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 Question number 4. Question number 4. A school has 10 classes with the same number of students in each class. One day the weather was bad. How many students? One day the weather was bad. 5 classes were half full. 3 classes were 3/4 full. 2 classes were 1/8 full. A total of 70 students were absent. How many were absent? Okay. So before I continue, I'm just going to mute everyone. Just really quickly, there's a lot of background noise coming through. Okay, awesome. So we have a total of 10 classes. Now, just a reminder, all of these classes have the same number of students. So the first one, we have 5 classes that were half full. Or another way to say it is that they were half empty. So how many classes were empty? 2.5 classes. Do you guys understand?
Yes.
Yeah.
Yes.
So 2.5 classes worth of
I don't understand.
Sorry, who was that?
Diona?
Which part do you not understand, Diona?
Like, how do we get 2.5?
So 5 multiplied by 1/2 or 5 divided by 2 gives you, what's half of 5?
2.5?
That's right. That's where we get it.
Okay. Okay,
Yeah.
thank you.
You're welcome. Okay. So, and then the next one, we have 3 classes that were 3/4 full. That means that 3 classes were 1/4 empty. Do you guys understand? Now, the reason I'm doing empty is because the final one is empty. And also it tells us that 70 students were absent. So it's just going to save us some time at the end if we just track how many of the classes were empty, right? So 3 classes were 1/4 empty. So what's 3 multiplied by 1/4? It is 3/4, which is the same as 0.75 classes. Do you guys understand?
Yes.
All right. And then finally, 2 classes were 1/8 empty. So that's the same as 2/8, which is 1/4 or 0.25 classes that were empty. All right, so let's add all of this up. What's 0.5 plus 0.75 equal to? 1 whole class, correct?
Yeah.
And then what's 1 whole class plus 2.5 classes equal to?
1.25.
Yes. No. 3.25. Correct?
3.5. 3.5.
Sorry, 3.5. So so just to be clear, 3.5 classes were empty, right? And that is equal to 70 absent students. Do you guys understand? So 3.5 classes is the same as 70 students. So how much is 1 class worth? So 3.5 divided by 3.5 gives you 1. So what's 70 divided by 3.5?
Will
when
you
it's
explain that part again?
Honey.
yes. So I'm going to go into the next line. So I'm going to. So just a heads up, Sarthak, remain muted. Seth, Mir, could you guys all stay muted, guys? Remember? Come on, guys. All right, awesome. So I'll explain that part again. So I'm just going to go into the next line. So we found out that 3.5 classes were empty, correct? And we also know from the question that 70 kids were absent. So what that tells us is that 3.5 classes is the same as 70 students. Do you understand? Now I want to find out how many kids are in one class. Now, how do you go from 3.5 to 1? You divide it by 3.5, right? Because 3.5 divided by 3.5 is equal to 1. 100 divided by 100 is equal to 1. 1,000 divided by 1,000 is equal to 1. So 3.5 divided by 3.5 is 1. So on the other hand side, we'll do the same thing. 70 divided by 3.5 is equal to what? 20. So one class has 20 students, and this school has 10 classes.
So would
So
you
10
do 20 times 10?
So 10 classes is equal to 200. Do you guys understand?
Yes.
Yes. No, I don't understand. I think I just missed the whole part.
Okay, so if you did misunderstand, I would recommend coming back for the second hour. So when we're doing 6 to 7, just because I think second hour we'll have way less students and I can go through that again, especially if you missed the whole part. But I'll give you guys a few minutes to take a screenshot or take some notes on this, because I need to rub it out to do the next question.
In our class, the teacher used algebra.
Yes, so there's an algebra method as well. In the answer key, it has both, but I've just included this one. All right. Can I rub everything out?
Yes.
Awesome.
Yes.
Yes, sir.
No.
Yes, madam.
No.
Oh, sorry. All right. Question number 5. Now, question number 5, it's probability, but it's a bit, how do I say? It's a bit more challenging. And the reason it's a bit more challenging is you kind of have to think outside the box, because it's a question that tricks you. So it says that there are 3 houses available on a street. 3 people apply for the houses. Each apply for one house without consulting the other. The probability that all 3 apply for the same house is equal to what? So you have house 1, house 2, and house 3. And you have person A, person B, and person C. Now, basically, what's the probability that they all chose the same house, right?
1 by 3.
Now, how do we figure that out? So let's let me show it to you. Basically, the first thing I want to teach you guys is this. When you need probabilities that are, that have to happen after another. So by the way, again, just a reminder. So Mir and Elma and Joanna, could you guys please stay muted, guys? A lot of background noise coming through. Thanks, guys. All right. So just a quick recap of probability, right? Whenever you have, 2 events that need to happen at the same time, you multiply. So I'll give you an example. If you ask for a dice roll, so a 4 on a dice roll, and you need heads in a coin toss, we multiply the probabilities. Multiply the probabilities. When it could be either or of the probabilities, when the word is or, then you add the probabilities. Do you guys understand? So in this question, could you guys send it in the chat? In this question, do they all have, for example, does person 1, person 2, and person 3, do they all have to pick the exact same house? Is it an and, or is it an or situation?
And
That's right. It's an and situation. So because of that, we multiply. Now, most people, right, especially like when you first look at this question, you would just say, well, the probability of them picking the same house is 1 out of 3, multiplied by 1 out of 3 multiplied by 1 out of 3. Now, this is wrong. The reason it's wrong is because the last two people, the house they pick is purely dependent on the first pick of the house. Do you guys understand? So the first person can choose any house they want, but the last two people have to pick the same house as the first person. And because of that, the probability for the first guy is not 1 out of 3. It's 3 out of 3 because he can choose any of the 3 houses. But the other two people have to pick the same house. That's why it's 1 out of 3. Right? So then it becomes 3 multiplied by 1 multiplied by 1 is 3. 3 multiplied by 3 multiplied by 3 is 27. And that is equal to 1 out of 9. Do you guys understand? Yeah? All right.
Yeah, I do.
Yep.
Awesome. Question number 6. Paul's lunch is made up of 9 grapes, and the remaining is blueberries. Sorry. All right. Yeah. So yeah, 6 9 grapes and the remaining is blueberries. How many fruits are there in the lunchbox? So in this question, oops, wrong booklet. So close this booklet, close this booklet, close this booklet. Oh, oops, open up the wrong one. So term 2 gate booklet. Okay. So close this one. So in this question, we have grapes. Oops, grapes is equal to 6 over 9. Blueberries is then equal to what ratio? I mean fraction, guys.
What?
3
Three,
over
nine.
9.
That's right. 3 over 9. Do you guys understand?
Yeah.
Yep.
Now, what we now know is that there's 12 less blueberries than there are grapes inside the lunchbox, right? So that basically that means is that 6 over 9 minus 12 is the same as 3 over 9. You guys understand?
Yes.
All right. So now we do a bit of our algebra, right? Oh, sorry, of fruits. Fruits. Okay. So 6 and 9, so the total fruit minus 12 is 3 over 9 of the total fruits. So we bring the 12 across and we get 6 over 9 fruits is equal to 3 over 9 fruits plus 12. Because remember, when we learned the rules of algebra, when you move something to the other side, it becomes the opposite. So negative 12 becomes positive 12. Do you guys understand?
Yep.
Yes.
Yes.
Okay. And then I'm going to bring, so I'm going to, move all of this. I'm going to move all of this up here. Right. All right. And then we have to bring this across, right? Because we have to bring the numbers to the other side. So 6 over 9f minus, why is, oh, sorry. I understand why that is a bit, let me just correct that. Okay. 6 over 9f minus 3 over 9f is equal to 12. So what's 6 9th of the fruit minus 3 9th of the fruit equal to? What's that equal to, guys?
12. 12.
3 9.
Yeah, so 3 9. Yeah, so no. 3 9. So 6, no, 6 over 9 minus 3 over 9 is equal to what, guys?
3 over 9.
3 over 9.
3 over 9.
3 over 9.
So 3 over 9.
3 over 9.
3 over 9 fruits is the same as 12.
1 over 3.
Okay, cool. So it's equal to 12. So 9 over 9, or the total number of fruits, is equal to 36. Now that's a more like hard algebra type of way. You guys want to learn the easier way?
I did it a different way. I did it like
That's okay. Yeah.
I did it like
Sorry, Manal. I just want to save a bit of time because I want to go through writing at the end. So I won't be taking everyone's different methods today, just because I want to save a bit of time. And again, just a reminder, please don't make me have to name you out. Same students are unmuting themselves. Just a lot of background noise. Okay, so that was a hard way. That was the the algebra way. So someone else sent me a question about this. How is it 12 take away 6, 9 is equal to 3, 9? Well, it's from the question actually. So 6, 9 is the grapes. It says that, so here again. So it says that 6 9ths of the fruits is equal to grapes. And there's 12 less blueberries than grapes. So if you subtract 12 from the number of grapes, you get the same number of blueberries. And I got 12 from here. That's where I got it from, guys. Okay, so I'll show you a slightly easier way, right? Now, we know that blueberries is equal to 3 9ths, correct? And we know that if the difference between 6 9ths and 3 9ths is equal to 12 fruits. Do you guys understand? Yes?
No, I don't understand.
Okay. So, yeah. So in the question, it says that there is a difference of 12 blueberries than grapes because it says 12 less blueberries than there are grapes. Do you guys see it in the question?
Yeah.
Yeah, it's right here.
Yeah.
Yeah. So the difference between grapes and blueberries is 12 fruits. Do you guys understand?
No, I don't understand how it's in between both of the fractions. It's 12 fruits.
Yeah, so it's because the reason it's like that, Anvika, is because the question says that there are 12 less blueberries than grapes, right? So that means that the total number of fruits that are grapes is 6 9ths. The total number of fruits that are blueberries is 3 9ths. The difference between these number of fruits has to be 12 because there's 12 less blueberries than grapes.
Oh, yeah, because it says 12 less blueberries than grapes. So it has to be 12 in between.
Yeah, that's right. So another way to think about it is it also says that it's 6 9ths is grapes and 3 9ths is blueberries. And the difference between them as a fraction is what, guys? What's the difference between them in fraction wise?
3
It is-
9.
3
3
9.
out of 9.
So we know that 3 9ths is
3
equal to,
9ths.
so
3
we know that
9ths.
3 9ths is equal to 12 fruits. And because 3 9ths is 12 fruits, then 9 9ths is 36 fruits. Do you guys understand?
Yeah.
All right. Question number 7. Nico had half a cake left over from his party. The next day, he ate 1/3 of it. How much of the cake was left? So he already ate half the cake. So now half of the cake is left over. Does everyone understand that part?
Yeah.
Yeah.
So next day, he ate 1/3 of it. So if he ate 1/3 of it, how many thirds is remaining?
2/3.
So
2/3.
So what is 2/3 of 1/2? Oh, oops. What is 2/3 of 1/2? And that is equal to 2?
6.
Which is,
5 is 6.
Equals 1/3.
which is 1/3. Now 1/3, the question is tricky on purpose. 1/3 is the same as 4/12. You guys understand?
Yes.
Yes.
Okay.
Yeah.
Question.
Yes.
Next question. So question number 8. Tank A can hold 5 liters of water. So tank A, I'm just going to do TA, can hold 5 liters of water. If 1/10 of it is poured into tank B. So what's 1/10 of 5 liters? It is 0.5 liters. Do you guys understand?
Yes.
Yes.
Yeah.
Isn't that 500 milliliters?
That's right.
Yes.
Maybe 500.
All right. That's right. Okay. So 0.5 liters. And then you pour it into tank B will be 1/3 full. So 0.5 liters is the same as 1/3 of the tank. So what is 3/3 of the tank? It is 1.5 because you multiply this by 3 and you multiply this by 3.
Yeah.
Pretty easy.
Mhm.
Next question. Point A has coordinates 2, 2. What are the coordinates of its image point if it's translated 2 units up and 5 units left and reflected across the x-axis?
Do
So-
we use the Cartesian plane here?
Yes, we use the Cartesian plane. So let's start off by doing 2, 2. So 2 and 2, we have the x right there. Then it goes up by 2 units. So right now it's 2, but if it goes up 2 units, where would it be?
Two,
At
2,
4.
4.
4.
All right. Then it moves 5 units left. So it goes 1, 2 to 0 because we're at 2 right now. And it goes 1, 2, 3 to move a total of 5 units left. So where is it right now? -3,
Yeah, -3.
-3, and 4. Correct? Now, this
Correct.
is the axis. This is the x-axis. And this is the y-axis. Basically, this dot is reflected across this middle line. So do you guys remember when you guys were in kindergarten, you did those butterfly paintings?
Yes.
Yeah,
No.
Oh,
So for those of you who remember it, basically the butterfly paintings is where you paint on one half of the paper, like you paint like here, you fold it, and then whatever you paint on this side will automatically show up here, an exact mirror image. So when you reflect across the x-axis, this line here, this x will travel all the way down to the mirror image of this. Do you guys understand?
Yes.
Right. So
Yeah.
instead of it being at -3, 4, it will travel all the way down to -4. So it will be here. So it will now be at -3,
Melvin?
-4. Do you guys understand?
Yeah.
Okay. So the person said no. Tell me which section you got lost. Where did you not understand?
Melvin,
Yes. Yeah.
isn't it supposed to be C?
Oh, sorry.
Yeah.
I'm blind. I need to get Specsavers.
Oh yeah. And I also didn't understand.
Yeah. Which part?
Like I didn't understand the Cartesian
Oh,
card
you
yet.
don't have to worry about that. That's just
Yeah, I didn't understand that either.
that's just a fancy name for it. Sorry, guys. One at a guys, one at a time. So Hannah, the Cartesian plane, you don't have to understand the name of it. This whole thing is called the Cartesian plane. So it's just when you have these lines like this, X, Y. John, could you stay muted? Amir, could you stay muted? Mir, and that's your last warning, right? So please stay muted after you've asked your question, just because there's a lot of background noise. All right, guys, come on. Okay, but all right. So the people who have questions about this, ask me now, and I'll help you out. So let me know.
Excuse me.
Yes.
I have a quick question about the way we reflect it.
Mhm.
Because I thought the x-axis was like horizontal. So why don't we move it horizontally? Why do we move it vertically?
Good question. Good question. Because that's exactly how like mirroring works. It even though it's horizontally, right? What happens is I want you to imagine you're doing the butterfly thing again, right? Now, if you're doing a butterfly thing, and then your butterfly is here, if you fold it on this line, like imagine, the paper is folded along this middle line here, right? That's where the crease is. Would this X go here or would it go here? Would it go to A or would it go to B?
B.
It wouldn't go to B because we're folding it here. So how would it go from here to here?
Yeah, A.
Oh, yeah, A.
Do you understand?
Yeah, thank you.
Yeah, do you get it? Yeah, do you understand, right?
Yep.
Now here's the other thing. If you were to fold it instead on the vertical line, you have a piece of paper and you fold it in the middle like this, would X go here or would it go here? Or would it go here? C.
B.
It would go to B because you're folding it in the middle at this line, correct? Right here. Do you guys understand?
Yep.
And then if you were to fold the paper in this line, you need to like visualize this. Where would the X go? Would it go to A, B, or C?
C.
That's right, because this is the middle line and it's basically the exact opposite of the line. Do you guys understand?
Yep.
Yeah.
All right. Does anyone else have any more questions about question 9?
I do.
All right, tell me. Tell me.
So like, I don't get the part. Like, do you move like clockwise direction?
No. You follow the question. So you don't have to do clockwise or anti-clockwise. The question just simply says you go 2 units up. So that's what we did. We went from here to 2 units up. Then the question says 2 units to the left. So we went 1, 2, 3, 4, 5 here. And then it says reflect along this line. So we reflect it to here. Do you understand?
Oh, okay.
It's just step by step by step.
I'm confused with the measuring bit,
Which measuring bit?
like with the numbers and stuff.
You mean describing what the units are?
Yeah.
All right. So it's basically, it starts off at 0, right? And then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9 to infinity. It goes on the left, it goes -1, -2, -3, -4, -5, -6 to the infinity. It goes up 1, 2, 3, 4, 5, 6, 7, 8 to infinity. And then -1, -2, -3, -4, -5 to infinity. Do you understand?
Yeah. Okay.
All right.
Thank you.
Now here's the thing.
Um,
You measure the X axis first because X comes before Y. You understand?
Yeah.
So
Yeah.
measure -3 first before you measure -4 here. Do you understand?
Yeah.
Awesome. All right.
No.
Yes?
for gate, will there be the z-axis as well?
No. All right. So question number 10. A circle with the radius of 2 is drawn at the center at -5, 2. The shape is translated right 4 and down 3. What is a center now? So again, you don't need to draw this, but it helps to visualize. So here is my little, drawing of the plane. And then remember, we go x-axis first. So on the x-axis, where is it? -5. So it's 1, 2, 3, 4, 5. So it's up here. And it's on the y-axis, it's 2. So 1, 2. So the circle is around here. Do you guys understand?
Yeah.
And then it goes right 4. So it goes 1, 2, 3, 4. So the circle's here now. And then it goes down 3. So it goes 1, 2, 3, and -1. You guys understand? So I'll draw this a bit better to visualize. So let me draw it a bit better. So it starts off at 1, 2, 2, 1. This is 0. Then it's -1, -2, -3. We have 1, 2, 3, 4, 5. So right now the circle is up here at 5, -5, 2. Do you guys understand? Yes. And then it goes 4 units to the right. So it'll be here. And it goes 1, 2, 3 units to the bottom. So it goes here. Do you guys understand? So now the new measurement is -1 and -1. Do you guys understand? Yes?
Yes.
No, maybe?
No.
Yes.
But
Yeah.
does
No.
do these
Uh,
come in the gate?
They could these are just tools to help you guys depending on whatever question come up and get. So the questions won't be just like this. You will see more of the questions that will show up in GATE in the mock exam that's coming up, and then definitely in next term and the term after.
Okay.
So people who don't understand, unfortunately, we're just running out of time, and it's fairly straightforward. I think you guys just need a bit of time. So stay back for the session from 6 to 7, and I'll spend more time on that. Sounds good?
Yeah.
All right.
Yeah.
Now, this circle, it says that it has a radius of 2. So this is a circle. It's got a radius of 2. Now, it's enlarged by a scale of 2. That means it's doubled times 2. Do you guys understand? So now the circle has a radius of 4. So what would its diameter be?
8.
8.
8. Perfect. All right. Back to the more fun questions. We have probability stuff. Okay. So let's go through some of these questions. First one, we have Helena has a fair coin and a wooden cube. On the cube, there's 2 faces, color green, 2 blue, 2 red. Helena flips the coin, getting both the tail of the toss of the coin and a green face. What is the probability of getting both a tail on the toss of the coin and a green face? Now, here's the thing. Remember what I taught you guys earlier? And so what do we do in this question? We have to
Times.
So what's the probability of getting a tail? 1/2.
1
And
under
what's the
2.
probability of getting a green face?
1 out of 6.
1 out of 3.
2
No.
out of 6.
1 out of 3.
0.
Alright.
6. 5 or 6.
Two
Oh,
over
2,
6.
2 out of
Guys, I need you to read your questions carefully, right? The question, it says a cube, and if you guys know your cubes, it's the 6 faces. For some reason, you don't know what a cube is. They say that there's 2 greens, 2 blues, and 2 reds. Quite often, the questions that I'm having to repeat is because you guys are not reading the question carefully, right? So there's 2 greens and a total of 6 faces. So the probability of getting a green is 2/6. Do you guys understand?
Yes.
All right. So you multiply these 2 probabilities and you get 2 over 12, which is the same as?
1 over 6.
That's right, 1 over 6. Question number 13. Now, this is a challenging one. You have 10 red, 10 orange, 10 green, and 10 blue. You empty the teas into your golf bag. What is the probability of grabbing out 2 teas of the same color in a row for you and your partner? So the first thing is, it doesn't matter which tea you pull out first, right? If it's red, blue, green, or whatever, right? What matters is that like the second one has to be the same. So the first person, they have a probability of 40 out of 40 because it doesn't matter which tea they pull out. Do you guys understand?
Yes.
The next person, let's just say the first person chose a red. The first person chose a red. How many red teas are left in the second box now?
9.
9.
How many overall teas are there?
39.
So
39.
39.
that's why it is 9 over 39, because this is the same as 1 over 1. You guys understand?
No.
Okay. So the people, again, so for the people who are not understanding, join me for the second session. And could you guys, if you guys feel like you guys are consistently finding most of these questions hard, and you're not understanding it in the first session, I'd recommend from next week onwards joining the second session. That way we can have, more attention for those kids who are struggling the most. Question number 14. Monique has a box that contains the following: 5 yellow marbles, 3 green marbles, 2 orange marbles, 2 blue marbles. She randomly selects 2 marbles from the box and keeps them. If she randomly selects a third marble from the box, the probability that she selects a green marble will be 2 out of 10. Which of the following statements would be true about the first two marbles she selected? All right. How many marbles are there in total?
Twelve.
Oh,
All right.
Well,
So she selected two.
Twelve.
So she
And-
selected 2 marbles. Guys, come on. If you guys, spam like that on purpose, it's quite annoying, I'll kick you out if you're consistently doing that. But yeah, I just need the answer once. So there's 12 marbles in total, right? But now, after you pick 2, how many marbles do we have left in total? 10, right? So now, the thing is, it says that the probability that she now picks a green marble is 2 out of 10. But how many green marbles were there in total before?
3.
3. So for the probability to go from 3 out of 12 to 2 out of 10, that means one of the 2 marbles she selected has to be green. Do you guys understand? Yes.
yeah.
Yes.
So one was yellow, one was green. This makes sense. One was orange, one was yellow. This is incorrect. Because if this was true, then the probability of picking a green wouldn't be 2 out of 10. It'd be 3 out of 10 because all 3 green marbles will be left behind. Do you guys understand? Both are green. This is also incorrect. Because if you took 2 greens, it would turn into 1 out of 10, not 2 out of 10. Do you guys understand?
Yes.
If both were yellow, that means that all 3 green marbles will be left behind. So the probability has to be 3 out of 10, but it's actually 2 out of 10. The only one that makes sense is A. You guys understand?
Yeah.
Yeah. Yes.
Reggie is trying to get to class from his home. Reggie wants to be late for class as he forgot to do his homework. So he walks 80% of the 10 meters and walks backwards 33% of 9 meters every 5 minutes. So every 5 minutes, he walks forward 80% of 10, which is 8 meters, and backwards 33% of 9 meters, which is 3 meters. So that means every 5 minutes, he does 5 meters in total. Do you guys understand?
Yeah.
Now,
Yes.
he needs to walk 200 meters. 200 meters. So 200 divided by 5 is equal to 40. And it takes him 5 minutes to walk 5 meters. So 40 times 5 is
200.
200.
Or an easier way of solving it is kind of like this. If you guys didn't get that math, an easier way of doing it is this. Every 5 minutes, he walks 5 meters. So every 1 minute, he walks 1 meter. So that means 200 meters will take him 200 minutes. Do you guys understand?
Yes.
All right, final question. A large picture takes up 1/5 of Gary's wall. If you replaced it with a bigger picture that covered 1/4, how much less of the wall can be seen? So it's as simple as 1/4 minus 1/5. We need to have a LCM, which is 20, which is 5/20 minus 4/20, and that's equal to 1/20. And the answer is B.
Melvin,
Yes.
I have another way of doing it.
Okay, that's okay. This is the simplest version, guys.
Melvin,
Yes.
for the previous question, was the answer C or D?
Let's see. Okay, so 200 minutes. Now, what's 200 minutes? It's the same as 3 hours and 20 minutes, because 3 hours is 180 minutes, and 20 minutes, add them together, and you get 200.
Okay.
Only 20.
Melvin.
Okay, so now I want to go through some writing. I want to go through just an overall, reminder of everything we learned in writing. So just a quick, recap. So overall, now a lot of you guys do, or tend to get confused about the writing section at Loyola. because in school you just have to do a simple writing. It could be just like they're just testing you on your ability to do English itself, just the rules of English. But in the GATE exam, what they're wanting to know is your ability to have a unique and a creative piece of writing. Now that's easier said than done. How can you make your writing unique? So this week, most of you in class would have gone through the thinking outside the box routine, right? Now in that, guys, you should have realized that most of you guys, even in a small class of 10 students, if you guys are all given the same topic, you guys come up with the same idea. Now think about the greater, total number of students you have. There will be around 6,000 or 7,000 students doing the same GATE test as you guys. How can you stand, out from them? And that's why we have the rules that we have, right? Think of a metaphor, use a topic as a metaphor. Like, for example, last week we had the topic of a man on a ladder. A lot of you simply wrote about a man trying to climb a wall. Now, that, in my opinion, that was a bit of lazy thinking, because the topic was very, very easy to think of ideas for. It was a man who was using 5, 6, 7 ladders to climb a wall. When all he needed was a single ladder, right?
Melvin. Yes.
Guys, please don't disrupt while I'm speaking. Remember, I'll answer your questions at the end, okay? So he only needed a single ladder to climb the wall, but he was using 5, 6, 7, 8, 9 ladders. Now, if you were to take some time and you were to, look at the image and think, what does that mean? Basically, it just meant that it doesn't matter how many, tools you have. If you don't know how to use the tools that you do have, none of them would be useful, right? For a man who has the most expensive, hammer and, I don't know, the most expensive shoes, if he doesn't train to run properly, or if he doesn't know how to use a hammer properly, it doesn't matter how expensive of a hammer he has, he won't be able to use it. Do you guys understand? So the story should have been something along the lines of being able to use the things that you have properly, or understanding to use the tools you have properly. So you could write a story about yourselves or a friend you have. For example, you might have a friend who goes to tuition, gets all these practice questions, but doesn't take some time to revise or pay attention in class, take notes, do homework. But she goes to 10 different tuitions. She goes to Loyola, North Shore, Coolmont. Every tuition that's in Perth, she just goes to every one of them, but she's not improving. So then you could write a story about that. Why is that possible? Because it's not about how many tools you have. It's not about how many different things you have, how many resources you have. It's about being able to use the ones you have to the maximum potential. Do you guys understand? So this is what I mean. So, one second. So as I mentioned, so this is what I mean. That topic was very, very straightforward. In GATE, sometimes you could get very random topics that don't have any sort of meaning. Like I got a picture of keys. Keys, like it doesn't have an obvious meaning behind the image. That topic, the one I mentioned about the ladders, that was pretty obvious. The topics that we used before, so let's say in the previous years, so this year, this year's GATE test, the topic was a house full of sand. That is pretty vague. It's a bit random, right? So you have to stop and ask yourself, okay, instead of writing exactly what you see, right? Instead of just jumping straight into it, take a moment to think, to pause, to reflect on what the image could mean. There's a famous quote by Abraham Lincoln. If you guys don't know who Abraham Lincoln is, he's a guy in America. He was a president, and he was the one who banished, slavery. So America used to have slaves, so he banned slavery. So Abraham Lincoln said that if he had to chop down a tree in 6 hours, he would sharpen his axe for 5 hours. Basically, what he said was that preparation is more important than hard work. Do you guys understand?
Yeah.
So when you get the topic, it's more important to prepare and think before you start writing. So let's take a look at the example of a house full of sand. don't just jump in straight away and write a story about a sandstorm that hit your house and your house was filled with sand and then how you had to fight against it. That is the exact same thing that the other 3,000, 4,000 students who do the gate test with you will write about, because most of you will write about the same thing, right? You will be the exact same as everyone else. So how can you stand, different from them? So a house full of sand, what could that symbolize? Well, first of all, sand is not supposed to be inside the house, is it? Right? So it could be talked about, for example, and you could say that a house that's not looked after will be filled with sand, right? It'll be filled with dust. So if you want to look at, be sharp and clean and everything, you need to look after things. You can't let things slide. So you could write, for example, in your own story, write a story about a kid, or for example, I should say how you were really, really smart in primary school. And, you were like the house that was fully kept clean and brushed. And every week you would, clean the house metaphorically, where you would, study and revise and everything. But because you were doing so well, you stopped caring and studying in high school. And soon enough, the house was full of sand. Your brain was too lazy now. You don't remember anything. And you have to work so much harder to get all this out to be as good as you were before. You have to work 10 times as hard now to catch up. You guys understand?
Yeah.
So
Mhm. Yep.
now, thinking about those ideas, it's not very easy. It takes practice, right? It's not something that you would naturally think about. You need to practice with your mom and dad by asking them to give you a random topic. Like, for example, a water bottle, a table, a chair, the wall, paintbrush, makeup brush, dishwasher. And with all these random objects, you have to think about seeing how you can describe it in a unique way, right? And that helps you build that skill up over time. Now, here is the kicker. Here's the main catch. I want you to think about something unique that is not the topic, but at the same time, you have to include the topic. So when you write about the house full of sand, but you're talking about a student who doesn't work hard anymore, you still need to make a clear connection between the house full of sand. So one of my students in Monday, the Monday Yokai class is a class that I'm training a new teacher in, right? So our teachers go through 3 months of training. So in that class, the teacher was marking a writing, and the topic was the man with ladders. And the student was very smart, and the student figured out that it was about common sense, that this person didn't have common sense, right? But the student didn't make a link to the ladders itself. They only talked about common sense. So the marker was in a bit of a dilemma. The marker said, well, this is good, but what can I do? They didn't talk about the topic. So I told her that just for this week, give them the good marks, because that's what they deserve. But they need to make sure that they include
Melvin.
1 second, bro. Like, as I mentioned, like 3 times now, right? Don't disturb while I'm speaking, just because it ruins the flow of the lesson, right? Come on. So as I was saying, even though they were, sorry, I lost track. Where was I? Yeah. So even though the topic, the person didn't talk about the ladder. So even though you talk about something that's unique to the topic, right? Even though you're not talking literally about the topic, you still need to make a connection. Do you guys understand? Doesn't matter what the topic is, you still need to make a connection. Do you guys get it?
Yep.
All right. So for my friend who's been asking me, and multiple times now, what the topic is, I'll share it with you. Just give me a moment. I'll put it up on the screen. But yes, you should have gotten it in the WhatsApp group chat. So you guys should be already in that group and just checking there. But I'll show you what the topic is now as well. 1 second.
Melvin? Oh. Melvin?
1 second, ma'am.
Mhm.
Stop.
All right. So here's the topic. Does that help, sir?
Melvin?
That's a writing topic. Okay.
Melvin,
Yes. Yes. Yeah. Yep.
are you are you getting like photos from the internet? Like
Yes.
random photos?
Random photos. Yep.
Melvin,
Yep.
can you write like a news report? Because I wrote a news report about this topic.
Yeah. So yes, you can write a news report. That's right. Yep.
Okay.
Melvin?
Yep.
Can you like describe the topic a little?
No, because that's what pretty much most people will do.
Melvin?
Yeah.
Can you write a real life story about this?
Sure. Just as long as you can have a unique spin to it, as long as it's if you write about the actual topic, but you're still unique from everyone else, I think you will do good. But
I think everybody is trying to write about the missing
I'll-
plane crash. About
good. Exactly. Minal.
Yeah, the Columbia's plane
Min-
crash.
Yeah, Minal's on track. Like literally, if you write a story that's just about a plane crash or a plane in a forest, you will not do well because that's what everyone will write about, right? Everyone will literally write about a plane in a forest or a plane crash or something along those lines. So don't do that if you want to do well.
Does the story
Melvin.
Okay, could you do me a favor? Could you guys all send your questions in the chat so I can quickly go through them? So just send them in the chat. When is the GATE mock exam test again? It's in 2 weeks' time. So not next week, the week after. All right, next question is, I see. I will chat. Thanks for telling. How long will the mock exam go for? It will be 2 hours long and you'll have a 10-minute break in between instead of the 5-minute break. Have we just started? No, the second session will start soon. Did you pass the GATE exam? Yes, I did. So I was at Perth Mod. So week 9 is a mock exam. That's right. Can you answer my old question? I don't understand which question that was. Do we have mock exams in class? Yes, you will. What do we do next week? We'll go through the week 8 homework. Are you allowed to leave the story in a cliffhanger? Preferably not. Preferably not. For writing, do you need to write it by hand or can we type it and bring it in? You have to write it by hand. You cannot type it in because in the actual GATE exam, you won't be typing it as well. When is the mock exam? 2 weeks' time. The writing topic is right here, guys, for next week's homework. If everyone writes outside the box, won't everyone's writing be the same? Very good idea. Very, very, very good question. Interesting question. I love it.
I was thinking.
Yeah, but it's unlikely. I doubt everyone, will be the same if they think outside the box. When you mean use a topic as a metaphor, do you mean directly linked to the, do we need to directly link to the plane first? Yes. So even though you use it as a metaphor or like in a different way, you still need to link it. How old are you? In my class, people are saying you're 48. I am actually 95. All right. I'll see you guys later. There's just a lot of random questions. Okay. All right. I'll see you guys later. I have to get started for my next session. See you guys.
Does the story have a moral?
Yes.
Bye.
You can have more.
Melvin?
Bye.
I gotta
Bye.
Bye
Bye.
bye.
Bye. Bye.
Bye.
Melvin.
Bye.
Bye.
All right. See you guys. Ta-ta.
Melvin, I have a